What I'm just going to talk about now is gravity. That sounds a very serious subject, but of course it's the fundamental idea in how the universe is organized, or what holds the solar system together, what holds the galaxies together, and most down to earth literally is the what is involved when an apple falls from the tree. It was said that Newton started thinking about gravity because he wondered why the apple was falling from the tree, and he ended up deciding that the force leading the apple to fall from the tree was the same force as meant that the moon went round the earth and didn't move further away, or it didn't move nearer. This is what held the moon in position, and what he said what holds the planets in position in relation to the sun. So that's gravity. Now, there was a program the other day by Melvyn Bragg on the BBC in a program called In Our Time, where he had people talking about gravity. And what was clear from this program is that there's something wrong with our ideas of gravity. Something wrong, in fact, with cosmology and our ideas about the universe and everything else. There are all sorts of puzzles, unsolved problems. So there are all sorts of puzzles about gravity. Some of them are sort of very fundamental ones in the remotest reaches of physics theory. The question is, how does gravity relate to what they talk about as dark energy and dark matter? A very basic one which physicists have been struggling with for years, or ever since Einstein, is how you fit gravity as this universal force to all the most fundamental features of matter, and that is to the whole area called quantum mechanics. It's unsolved. They search for a theory of everything, and they haven't found a theory of everything. And a lot of the trouble is that there's something wrong with ideas about gravity. Now, Newton, it was said, started thinking about gravity because he saw an apple fall from the tree, and he wondered why it fell and what was producing the particular phenomenon of the apple falling. And he ended up with a massive theory, the theory of gravity as a force of attraction. The apple was attracted to the earth, and he said in the same way the moon was attracted to the earth, and the planets are attracted to the sun, and the whole system, the solar system, is held together by gravity. And though Newton's knowledge of the universe was much more limited than the knowledge we have now, it didn't extend much beyond the solar system. And now we know there are billions of galaxies, and billions upon billions of stars, and immense spaces. And we have all the theory about the origin of the universe, the idea of the Big Bang and all that sort of stuff. But we still see that there's something wrong with our ideas about gravity. Newton had a picture of the universe, that is the orderly arrangement of all the astronomical bodies under the influence of gravity. And then of course Einstein had another picture. These are just visual pictures. The calculations remain the same in terms of the rate at which the apple falls to the ground and so on, and the strength of the pull on the apple, and these remain the same regardless of the larger picture. And the larger picture is probably absolutely wrong. What's been found recently is that things odd are happening in the universe. The universe, they find, seems to be expanding when they expected it to be either stable, stationary, or contracting. So, as a result of these new astronomical discoveries, cosmologists, that's people who concern themselves with the character of the universe and the formation of the universe and the end of the universe, have had to come to accept that there seems to be some repulsive force operating in the universe. This is very surprising, of course. It means that Einstein's account of the universe has had to be adapted, varied, or made to fit the new facts. So there is a repulsive force. But how do you accommodate gravity operating in one way as an attractive force and gravity operating in another, apparently, as a repulsive force? Maybe we should change our picture of the relation of gravity to the universe, to the galaxies, to the Earth and everything else. Look again at the apple falling to the ground. Is the apple falling to the ground, or is it being attracted by the Earth, whatever attraction is, or is it being pushed downwards to the Earth? The apple falling to the ground, yes. Is it being pushed rather than being attracted to the Earth? What happens if we start thinking of gravity as some universal repulsive force? And then we get something which goes to explain the expansion of the universe. And also, maybe, it gets away from the idea of gravity as a mysterious force operating across empty space in a way that is totally unexplained.